section of the video, I'm going to show you the steps that I carried out, or the history of the design of this bevel gear. So I use Fusion 360 to design the gear, and then the material for this gear is plastic PTG material. So as this lower section of the screen shows the history of the model gear, 3D gear. So to begin, let's do the inspection. So this gear has a length of the length of the bow is around 18.5 millimeters. Here, that's 18.5. That's the length of the gear, and then the central hole, or the bow where the driven shaft is mounted, or where the central shaft passes through, is around just a diameter of 8.1 millimeters. And also for the outside diameter, let's try and see if we can find the outside diameter. You can estimate. So the outside diameter of this bevel gear is around 32.2 millimeters, and then for the pitch diameter, you can try and estimate the pitch diameter here. So the pitch diameter is also around 29 millimeters. That's the pitch diameter for this bevel here, and it also has a QA, or it's not entirely a keyhole, but it does the function of the keyhole. It's used to reinforce the central shaft, or the shaft that goes through the bow. Its diameter is around 4. So an M4 screw is strong enough, or is well enough to reinforce the central shaft, and so it goes from end to end. So the length of that screw should be more than the diameter, a little bit more than the diameter, or even equal to the diameter of this this section here. And it also has a flat part here. The hole has a flat part, and that flat part is it also helps in reinforcing the shaft. It measures with the shaft, so the shaft also has this flat slot that measures with this same section as that of the gear. And the gear is 15 teeth gear. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all up to 15. So let's go straight up to the history, or the steps that I took. So I started with this cylindrical section, and then after that I created another section here. That this face is where the actual gears are placed. So after that I created another offset plane, and then using the loft feature, I then created a sketch of a lesser diameter, this sketch here, and then applied the loft feature to create this conical shape. So it's on this surface, the surface of this conical shape, that I then created the teeth of the bevel gears. So I did some filleting on this part, this lower part, and also I decided to create another plane. That is, this plane uh, is tangential to this conical surface. It's now allowed me to create this tooth here. So there is this first sketch, and then I created another second sketch. So this that plane allowed me to create this sketch easily. But since that the teeth of the bevel should not be so much cylindrical as such, I decided to create another profile. As you can see, this profile, this, and then let's see how it looks like. And then now this is the profile of the teeth here, the final profile. This is how it looks like, this one. And then after that I did some filleting to make it a little bit rounded edged. And then I created now, oh, I patterned this tooth profile. I created a circular pattern all around here. And then after that I also created this bow, this hole here, that I used the same function for extrude and then cut, extrude, cut. And then after that I created this slot, and then replicated the slot back into the inside bow. And I also created the keyway or the screwway, and I also did some filleting. And then that's the final gear that I came up with. So thank you for staying tuned, and I'll show you the final manufactured gear shortly. It's made of plastic PTG material. Thank you.